All right, welcome calculus nerds. So we're going to transition, we're going to make a big jump now here. We've been finding derivatives for several weeks, and now we're going to do the reverse process. It's called anti-differentiation. It's the reverse process of differentiation. Just like add and subtract are inverses, multiply, divide. All right, differentiation has its reverse process called anti-differentiation. By the way, it is pronounced anti-differentiation, not anti. Anti sounds like you're against something. So again, you have the pictures of my favorite aunts. My dear Aunt Sally, please excuse my dear Aunt Sally from the order of operations. And then of course here would be my anti-differentiation. All right, rock on, Auntie. So we're going to do the reverse process. This is just an introduction here. So again, if you would look at the notes, Roman numeral 1, the idea is, suppose we give you the derivative of a function, f prime of x equals 3x squared minus 2. And again, I would prefer to present this in sequence, that you have the whole thing in front of you. So if we give you the derivative, what's the original function? Think backwards, all right? Now we'll have some rules to follow for this. I don't know why I just spun around there. But anyway, we'll have some rules to follow for this. And I was hopefully giving you one here where you could think backwards pretty well. And you would say, well, let's see, what would you take the derivative of to get 3x squared? And I hope you would agree that would be x to the third. The derivative of that is 3x squared. Yay! All right. And then what would you take the derivative of to get 2? How about 2x? So there you go. That would be a potential reverse logic. All right. So this is, we're going to talk about this. It's called the antiderivative of that. And that would be one expression that could be the antiderivative. But if you think about it, if you were to add a number on the end, like plus 5, see if we stuck a plus 5 on there, you take the derivative of that, it'd be 0. This would still have a derivative equal to that up there, wouldn't it? So plus 5 would work. Could we tack a minus 9 on the end of this? Sure. Because again, if you work backwards and take the derivative of this, you'll indeed get that expression above. So you can tack a number on the end and it won't mess things up because again, the derivative of any constant is 0. So the point is there isn't really just one answer. What we do generically is we say, all right, we need the x cubed minus 2x to create these terms. And then we could just add any constant on the end and it would still work, wouldn't it? So that's the general way we write this, is these terms and then plus any constant on the end. So again, looking at the notes, and you can pause at any time you want, but it's really a whole family of antiderivatives depending upon the different values of c. And so the thought would be we have a function, and if we take its derivative, all right, that's what we've been doing for several weeks. We take a function, find its derivative, we go from f to f prime, but now we're going to think the other direction, and we're going to start with the derivative and think backwards and find the original function. So if we have the derivative and we go back to the original function, this is called the antiderivative. So that's just a quick overview of this. We're going to talk about changing our brain in the other direction, and we'll introduce some very specific rules about how we go about finding antiderivatives. So think backwards now, that's the point. All right, so think backwards. Better look out, I'm going to fall down.